to the cloud. I think now it's recording. Okay, perfect. All right, guys. So let me just remind you very quickly. So what we discussed like 2 weeks ago. First, we talked about the frequency tables. So we said frequency tables are used to partition, your data values into classes and intervals. Frequency tables are used to partition your data values into classes and or intervals. Okay. Anyway, so I'm going to do an example, which is kind of similar to the homework. So I mean that will help you probably. If you didn't do yet your homework, then I think that will be a good exercise. So so here's an exercise or example, and I'm going to show you how it works. Of course, exercise. Okay. So let's say the following data. So the following exercise or example. I think we did this exercise 2 weeks ago, but I'm going to just remind you how to do the frequency table. Okay, so so let's say that the following data values, let's say they represent. So the following data, let's say represents the goals scored last season by soccer teams in the MLS Eastern Conference. Okay, MLS Eastern Conference. Okay. So let's say you want to construct, or so let's or make a frequency table. So let me just first write down the data values before the question. So let's say, so the first team, let's say, scored 6 goals. The second team scored 12. Third team in the MLS Eastern Conference scored, let's say, 16, 17, 20, 21, 22, and then 24, then 27, 30, 31, 31, 34, and then 36. All right. So the question, which is very similar to the problem in the homework. So let's say you want to construct a frequency table with let's say 4 classes. So the number of classes, guys, depends on the problem. Like, so if you check your homework, I think in the homework, the first problem, it says like make a frequency table with 6 classes, right? And this problem number 1, it says make a frequency table with 4 classes. But then the second problem, there are like 6 classes, right? You need to make a frequency table with 6 classes. So the number of classes depends on the problem. It's not always 4, or it depends on the problem, right? So like in the homework the problem number 2, in the homework, it says 6 classes. Okay, so the number of classes depends on the problem. So with 4 classes, that includes So I'm gonna just do the same thing like in the homework. So in the homework, the data represent like the first problem, data represent the test scores in the first problem. In the second problem, the data actually represents the salaries for employees of a small company, right? So our data in this example here represent the goals scored by the soccer teams and the MLS Eastern Conference. Okay, so and now as you can see in this problem, how many data values we have. So we have like 1, 2, 3, 4, 5, 6, 7. So it's 14, right? We have 14 numbers here, as you can see, right? So as you can see here, we have 14 data values. Okay. Like in the homework, like in the first problem, let's see how many, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's like in the first problem, like there are, I think, 18 data values. All right. And the problem number 2, there are like 4, 5, 6, 7, 8, 9, 10, 11, 12, there are like 24 data values. And in this exercise or this example, we have 14, only 14. So the number of data values depends, of course, on the problem. Okay. Now, so what you had to do is to construct this frequency table with that includes the first the class limits, 2 the class boundaries, okay, 3 the class sorry, not the class, but the midpoints. For the frequency, and then the relative frequency. Then the last column, it's the relative frequency. All right. So I'm going to explain how to do this very quickly. But anyway, I'm going to need this example later. Yeah, so first, step 1, I mean, the first step is always to compute. So step 1, we need to compute the width. Okay. So we need to find or compute the width. Okay. Now, how do we find or how do we compute the width? The width, you take the largest data value, largest number you have. Like in this data, the largest number would be, as you can see, that would be 36, right? That's the largest number. Okay, so it's the largest data value. Let me just write down here probably the formula. So largest data value minus the smallest one. Okay, and then you have to divide the whole thing by the number of classes. So this is number of classes. All right. So as I said, the largest data value, it's 36. That's the largest number in the data values here. Okay. So of course, this largest data value depends on the problem. So like in the homework, of course, you have different numbers. So it means we have different data values. So this largest data value is going to be different. Okay. But in this problem, the largest data value is 36. So it's going to be 36 minus. So here is 36 minus the smallest data value, so the smallest number. And so in this data, the smallest number is going to be 6, right? That's the smallest number. And again, so if you have a different problem, the smallest number is going to be different, right? So it depends on the problem. So, but in this example, the smallest number is 6, or data value is 6. And then the whole thing divided by the number of classes. So like here in this problem, the number of classes would be so we said we need a frequency table with, as you can see, with 4 classes, right? So we need to divide by 4. So it's divided by 4. All right. So 36 minus 6, that will be 30 over 4. So then 30 over 4 that would be, if you use your calculator, that would be 7.5, sorry, 7.5. Now, the width is going to be the next integer or the next whole number. Okay, so your width, in this case, in this problem, the width is going to be the next integer. So what do I mean by integer? I mean a whole number. Okay, so 7.5, of course, it's not a whole number, it's a decimal, right? Because of the 0.5. So the next whole number or integer on your number line would be, what would be the next integer or whole number on your number line? Well, that would be 8, right? Because, you know, these are have your number line here. This is 7.5. So after, I mean, the next integer on your number line would be 8. Okay. So the width in this case would be 8. Okay. All right, guys. Now next, that's the first step. This in the second step, step number 2. You need to find the data range, okay, for each class. Okay. Okay, so let me show you how it works, how to construct this, or how to make this frequency table. So, so here's my, say this is my frequency table. Okay, and so we're gonna have how many columns? So, so we have the class limits. So first we have the class limits. That's my first column. Second column, we're gonna have the class boundaries. Next column, we're gonna have the midpoints. Next, there'll be the frequency. Okay, and finally, we're gonna have the relative frequency. All right. Now, we said we want 4 classes, right? So we're gonna have like 4. We're gonna have like 4 rows. Okay, so this is first row, second, third, and there's the 4th row. Okay. Now, for the first class, guys, or first row, the class limits or the class interval. So the lower limit is going to be the smallest data value, or the smallest number. So like in this example, the smallest data value, it's 6, right? That's like the smallest number. It's 6, right? So the first class, the lower limit of the first class is going to be 6. So here, we're going to put 6 here. Okay, that's the lower limit of the first class. Now, for the second class, the lower limit is going to be 6 plus 8. Okay, the 8 is of course 8 is the width, right? That's the width. Okay, so what we do is we're going to add 8 to 6. So 6 plus 8, that's 14, right? So we're going to have 14 here. So 14 would be the lower limit of the second class. For the third class, lower limit would be 14 plus 8, right? So 14 plus 8, that would be 22. Now for the fourth class, lower limit, that's 22 plus 8. And 22 plus 8, of course, it's 30. All right. Excuse me? Is there a question? I can probably check the chat. Let me see the chat. Where's the chat? Here. Let's see the chat. Okay. I don't see any question in the chat. Okay. Now, so that's the lower limits, okay, of my classes. Now for the upper limit, guys, so what you do is just, you know, you take, so the lower limit of the second class, it's 14, right? 14. So for the first class, the upper limit would be 14 minus 1. So you have to subtract 1 from 14. So 14 minus 1, that will be 13. So here, the upper limit of the first class, it's 13. Again, I got 13 because that's 14 minus 1. 14, that's the lower limit of the first class. Okay. Now, for the next class, the lower limit, it's 22, right? So I'm going to subtract 1 from 22. That will be 21. So then the upper limit of the second class would be 21. So here, I'm going to put 21. Okay. Now, next lower limit, it's 30 of the fourth class. So then the upper limit of the third class would be 30 minus 1. That would be 21. Sorry, 29, right? So this is here, the upper limit would be 29. Okay. And then for the upper limit of the last class, so what we do, guys, as you can see here, the difference between 13 and 21, it's 8, right? It's 13 plus 8 would be plus 8 would be 21. So here the difference, as you can see, it's 8. And then to go from 21 to 29, it's also the difference, it's 8, right? So 21 plus 8 would be 29. And then so for the upper limit of the last class, that would be 29 plus 8. So then the answer, of course, here would be 37. So 37 would be the upper limit of the fourth class, last class. Okay, so this is how we find the class limits or the data range for each class. So any question, guys, how I got these numbers? I mean, please let me know. I know some of you have trouble with homework, so just let me know. Sorry?
I don't understand.
I'm sorry, I didn't hear you well, I guess.
I don't understand six for
How I got the 6.
I'm confused.
Yeah, the 6. Okay, so I got the 6. This 6, it's because that's the smallest number in the data values. You see here, what's the smallest number? The smallest number is 6, right? That's why I started with 6. You see this number here?
Yes.
Okay, the 6 it's the smallest number in the data values. On these numbers, the smallest one is 6, right? That's the smallest number. So that's why I started with 6 right here. So that's why I got this 6, right? Now, to move from 6 to 14, what I did, I added 8. So 6 plus 8, that's 14. Okay, now you may ask how I got the 8. Why? What's 8? Well, 8, that's the width, right? We computed in the first step, we computed the width, and we said where the width is 8, right? So that's why I added 8 to the 6. Now,
if the width is a different number, so we add that number.
Yeah,
to,
of course,
okay.
of course.
Like 7 or 6.
Yeah, like 7 or 6.
Okay.
Yeah, of course,
Okay.
absolutely. Yeah, depends on the problem. Yes, I mean the number of classes, the smallest number of data value, or the largest. I mean, all depends on the problem, of course. And then so yeah, 14 plus 8, as you can see, that will be this 22, and then 22 plus 8, that will be this. Oops. So this 22 plus 8, that will be the 30. So that's how I got these numbers here. Okay, I hope this makes sense. Now, for the upper limits, the 13, 21, 29, 37. So what I am saying is I got 13. So I got this 13 because this 13, it's just 14 minus 1. So I just subtracted 1 from 14, okay? So, and then I got this 21, that's because it's 22 minus 1.
Question. So
Yes.
you're always gonna take 1 away from the
Yes.
number?
Yeah.
Okay.
Yeah, just
All right.
take away 1, yes. Like here, 29, it's just 30 minus 1. Okay. Now, there's like a problem here with the 37 because there's no fifth class, right? It's just there are just 4 classes, right? So how do we find this 37? So what I was saying is that there's, as you can see, the difference here between like 13 and 21, it's 8. It's again the width, right? And the difference between 21 and 29, that's again the width, which is 8. So then to get this 37, you just add 28 to 29, right? That's how I got this 37, okay? Well, I hope this makes sense. Now, for the boundaries, all you have to do for the class boundaries, all you have to do, guys, is, so for the lower boundary, you have to subtract 0.5 from the lower limit. So here, the lower limit is 6, right? So I'm gonna subtract 0.5. So that'll be 5.5. Here, lower limit, it's 14. Okay, so I'm gonna subtract 0.5. That's 13.5. Okay, so you always subtract 0.5. Okay, it doesn't depend on the problem. It's just like a formula. Okay, so you always subtract 0.5. So like here, 22, you subtract 0.5, that'll be 21.5.
Sorry.
Yes.
I'm confused. 5.5, what is that?
The 5.5?
Yeah.
That's because I subtracted, I took away 0.5 from 6. So I did 6 minus, sorry, 6 minus 0.5. So that's why I got the 5.5.
Every number is 0.5?
Yes, you always subtract 0.5. Yes, like here I have 14. This is 14, right? So I subtracted 0.5. That's why I got this 13.5.
Oh, okay, I got it. Thank you.
Okay. Now, last, like the 4th class, I have 30 minus 0.5. That will be 29.5. Okay. Now, that's for the lower boundary. This is for the lower boundary. Now, for the upper boundary, we have to add 0.5 to the lower, to the upper limit. So here for the upper limit, I have 13. So we need to add 0.5. So that will be 13.5. Okay, so here we're gonna add point. So here you subtract, right? You subtract 0.5. Subtract 0.5 from the lower limit. Here you need to add 0.5 to the upper limit. So like here it's 21. I'm gonna add 0.5, so that'll be 21.5. This is 29. Gonna add 0.5. That's 29.5. Now this is 37 plus 0.5. That'll be 37.5. Okay, so for the lower boundary, you subtract 0.5 from the lower limit. For the upper boundary, you add 0.5 to the upper limit. Okay. Any question, guys?
You can repeat again, please. I can hear you.
Oh, you can hear me.
Yeah.
You hear me? Does anyone hear me well?
Yes, I do.
You hear me? Okay.
Okay, you're fine.
Yeah, I'm fine. Okay. Yeah, so I was just saying, so for this upper boundary, all you have to do is just add 0.5 to this upper limit, okay, to the 13, to the 21, to this 29, to this 37. So all I did was to add 0.5 to the upper limit, okay?
Okay.
Now for the midpoints, it's by definition is that's the average of the class limits. So what we do is we take the average of so the class limits of the first class. So the class limits are 6 and 13, right? So we take the average. So which means you're gonna add 6 to 13, so 6 plus 13, and then you have to divide by 2. You always divide by 2, okay? You always divide by 2, but because that's like the average. So yeah, so this is 6 plus 13, that would be 19 over 2, that would be 9.5. Second class, the class limits are 14 and 21. So I'm gonna add 14 to 21, and then again, always divide by 2 because that's the average. That's like the middle point. So 14 plus 21, that'll be 35. 35 over 2, that's 17.5. So this is 17.5. Okay. Now, next, it's 22 plus 29 over 2. Again, 22 and 29 are just the, as you can see, are just the class limits, right? And again, we take the average. So
I'm sorry, how are
yes.
you getting the 2?
The 2, it's that's the formula. They always divide by 2. That's like because
Oh, okay, okay.
We are computing like the average, so we always divide by 2. Next, it's 51 over 2. So that will be a sorry, not 51 over 2. So that will be 25.5. And finally, the last class, we have 30 and 37. So that's 30 plus 37 over 2. That's 67 over 2. And the answer would be 33.5. Okay. All right. So as I said, we always divide by 2 because that's the average. All right. So we have our class limits, class boundaries, and the midpoints of the class of the classes. Now the frequency. So what do I mean by the
Excuse
frequency?
me.
Yes.
22, 22 plus 29 equal
Yes.
25.
No. 22 plus 29, that's 51. And then we divide by 2, right? So what I'm saying, so what I said is 22 plus 29 over 2. So that's like 51. The top here, 22 plus 29, that's 51. And then you divide by 2, right? Don't forget division by 2. That's the 25. That's why I got 25.5.
Okay, I got it.
Now for the frequency, guys, the frequency, it's just the number of the data values in your class. So like my first class, the limits of my first class are 6 and 13. Of course, 6 is included, 13 is included. So I'm gonna count how many data values are between 6 and 13. So you need to get back to the values here, and you need to count how many data values or how many numbers are between 6 and 13. So between 6 and 13, as you can see, let me just erase this thing here. Let me just write again here, 6. Okay, so how many values are between 6 and 13? And as I said, the 6 and 13 both are included. So we have 6, that's between 6 and 13. 12, it's also between 6 and 13. Now, next number, it's 16. 16, it's larger than 13, right? So we have two numbers, the 6 and 12. We have two numbers between 6 and 13. And 6, again, it's included, okay? So we have two numbers between 6 and 13. So the frequency of the first class, it's 2. So here the answer should be 2, right? Again, it's because I have two numbers between 6 and 13. Now, Any question how I got 2?
No.
Oh, okay. Now, how many values are between 14 and 21? That's 14, 21. That's my second interval or my second class, right? This is my 14 and 21. That's my second interval. So how many values are between 14 and 21? Well, 16, obviously it's
I
between
think
14, 20.
it's 4.
4, very good. So we have 4 values between 6 and 21. 21 is included, right? We have to include the 21. So here next, so the frequency here would be 4. Let me just change the color to the green. Now, next class is it's between 22 and 29, right? So let's check how many values are between 22 and 29.
3.
Well, 22 here. This is supposed to be 24. Sorry, I think I erased the 24. It's supposed to be 24. So, yeah, so 24, it's between 22 and 29. 27, it's also between 22 and 29, right? But then 30, of course, is larger than 29. So we have 3 values between 22 and 29. Okay, so we have 3 values between 22 and 29. So here I'm going to put 3. And finally, for the last class, it's between 30 and 37. Let's see, let's count how many values are between 30 and 37. So 30 is included, of course, 31, another 31, 34, and 36. So we have 5 values between 30 and 37. So here is going to be 5. So this is 5. All right. Any questions so far? Now for the relative. Okay, perfect. So now for the relative frequency, guys, all you have to do. So let me just write down here the formula for the relative frequency. Relative frequency, it's equal to the frequency over the divided by the size of the sample. So let me just write it down here. So relative frequency, it's just the frequency over the size of the sample. So what do I mean by the size of the sample? That's the number of the data values. Size of the sample, it's just the number of the data values. How many numbers do we have? Let's see. Well, in our example here, of course, how many numbers we have? Well, it's 14 because there are 14 numbers, right? I mean, it's just and we have like 14 teams in the MLS history conference. We have 14 numbers, so the size of the sample is 14, right? So in our example, that would be 14. So here in our example, we have 14 numbers. So here we have 14 numbers or data values. Okay, so for relative frequency, guys, all you have to do is just divide your frequency by the size of the sample. So like for first class, the frequency is 2, right? So we have to divide the 2 by 14. Okay, so just use a calculator. 2 by 14. That's let's see how 2 over 14. Let me just check my nose calculator. So 2 over, I think it's 0.14. So this is actually the answer here. It should be 0.14. Again, 2. It's because the frequency it's equal to 2, and divided by 14 because we have 14 numbers. So like in the homework, guys, like in the first problem, I don't know how many, I'm not sure how, let me see. So like in the first problem in the homework, we have like, yeah, there are 18 numbers, like 18 test scores, right? There are 18 numbers. In problem number 2, there are like 1, 2, 3, 4, 5, 6, 7, 8, 24, thank you. like there are 24 data values, okay? So the size of the sample depends on the problem, depends on the question, okay? It's not, now, for the second class, the frequency is 4, we divide by 14. So then 4 times 14, that would be 0.28. Next, the third class, the frequency is 3, divided by 14 again. Now 3 over 14, let me check my, let's divide 3 by 14. Yeah, it's a 0.21. Right, and the last class, it's 5 over 14. 5 over 14, I think it would be 0.35 or something, 35, 36, 35. All right. Any question, guys? So this is very similar to the 2 problems in the homework. Is there any question, guys? I guess we can move probably to the next thing, histograms. I mean, we discussed a little bit the histograms last time, was 2 weeks ago. So I'm gonna just remind you very quickly the histograms, and then we're gonna discuss the shape of the histograms. Okay, any question, guys? Okay, I think now I think you can probably do the homework without any trouble. So yeah, let's move next. So we discussed, as I said, the histograms a little bit last time. So just to remind you very quickly, what's a histogram? So for the histograms, guys, so the idea is to, again, to display, we're gonna use it like graphical display. You wanna, for example, we're gonna display the frequency or relative frequency. You can always use the histogram. So histograms are used to just remind you what's a histogram. So histograms are used to display frequency or relative frequency. Depends on the problem. Okay. So there are basically 2 steps. First, you need, so step 1, I mean, to draw a histogram, you're gonna need, we need classes boundaries. Classes boundaries. And the frequency or the relative frequency, depends on the problem. And then the second step, of course, you're gonna draw the histogram. Once you have the classes boundaries and the frequency or relative frequency, then in the second step, you can draw your histogram. But to draw the histogram, you're gonna use 2 axes. There is a horizontal axis. So in the horizontal axis, you're gonna put the classes boundaries. Okay, and in the vertical axis, you're gonna put the frequency or the relative frequency, depends on the problem. Right. Okay, so I think last time I did just one example, and I think we didn't have time to do an exercise. I think we did an example with the speeds of the 24 cars on the highway. But we can well, probably let me first just remind you with an example how it works, and then we can probably do an exercise. I think the last time we didn't have time to do an exercise. So let me just example here, how it works. I'll show you again how it works. So yeah, so, and this is an example. So we have, so our data values. So the data values represent the speeds of, and this is actually an old example. We did the frequency table of this example. But anyway, just let me just remind you the example. So represent the speeds of course, on using miles per hour. Of 24 cars on a highway. Okay. So I mean, I won't give you again the speeds of this 24 cars. I'm gonna just remind you so we did the the frequency table, I think 2 weeks ago, or probably 2 weeks ago. I mean, in our last meeting. So we did the frequency table, and we got, so as classes boundaries, just to remind you what we got last time. So we did the frequency table, and we got, so as I said, for the histogram, guys, all you need is the classes boundaries and the frequency or relative frequency. Okay, it depends on the problem, of course. So let's say, so we got this frequency table of this example. So we have this classes, so we're gonna need the classes boundaries. Okay, and we need the frequency and or the frequency table. Okay, so I think we had like 6 different classes. So let me just remind you the classes we got, classes boundaries, I mean. So first class, we got 42.5 to 50.5. And then second class, it was like 50.5 to 58.5. And then here was 58, of course, 0.5 to 66.5. Fourth class, we got so 66.5 to 74.5. Fifth class, we have 74.5 to 82.5. And then the last class, we had so 82.5 to 90.5. All right, so we had six different classes. All right. Now for the frequency, I think we got for the first class we got 1 as frequency. So here we got 1. Second class we got 0, 1, 6.
Professor,
I'm probably just I'm gonna mute.
hello?
Can anybody else hear him? Because I can't.
Yeah, I can't hear him either. He muted himself.
I think he meant to mute the group chat, but
Yeah, but Professor, you're muted.
Okay. Sorry, I mute myself. Yeah. Sorry about that, guys. All right. Okay. Now you hear me, right?
Yes.
Yes.
Okay, perfect. Sorry about that. All right, so yeah, just to remind you this table. So we got this 6/24, which is 0.25. And then 8/24, of course, that will be this 0.33. Anyway, so just to remind you how to draw the histogram. So what we do is the following. So now so the question is, so we need to draw the histogram showing the frequency. Okay, so that's what I'm gonna do now. All right, so we're gonna have like a horizontal axis. So the horizontal axis is supposed to represent the class's boundaries. So here's my class's boundaries. Okay, so this is class's boundaries. All right, so this is just a number line. That's what I mean by an axis, right? It's just a number line. So on your number line, I'm gonna put 0 somewhere. Let's say here. Here's my 0. All right, and then I'm gonna put the class's boundaries. So class's boundaries, guys. The values of my class's boundaries are just right here. As you can see, these are my class's boundaries. So I'm gonna put my class's boundaries on this horizontal axis. So first value, it's 42.5, right? Next class boundary value, it's 50.5. Next, 58.5, 66.5, 74, 82.5, and then 90.5. All right. Any questions so far, guys? So you see how I got these numbers on this axis, right? It's just they represent the class's boundaries.
I'm confused.
Yeah, please go ahead.
Class boundary 42.5. What is that?
How I got this 42.5, that's the first value right here. You see this 42.5? And then we have 50.5. That will be this value right here. Then 58.5, that will be this number here, etc. Of course, this is just a 50.5. It's just the same number, right? And then after that, we have the 58.5, etc. 66.5, the 74.5, etc. Does it make sense? I hope so. All right, so that's my class's boundaries. Now I need the vertical axis, and on my vertical axis, I'm gonna just put the frequency. So this is my vertical axis. So here I'm gonna put the frequency. Okay. So I'm gonna probably just erase this thing here. Okay, so frequency, guys. So as you can see in the table, we have 0, we have 1, we have 6, we have 8. So we're gonna need, well, we start with 0, and then we have like 1, 2 units, 3 units, 4, 5, 6, 7, and then 8. Okay. I'm gonna just need 8, right? Because that's like the largest number, largest frequency. It's 8, right? Now, next, so I'm gonna represent the frequency of my first class. So my first class, the class's boundaries are 42.5, 50.5. So here is this interval here. You see this interval? This interval represents my first class, right? The first class, it's the limits are or boundaries are 42.5, 50.5. So this interval here, this represents the first class. This is my first class, right? Now, the frequency of the first class, it's 1. So I'm gonna draw like a box, the height equal to 1. So here's my box. And the height of this box, guys, it's equal to 1, right? You see here 1? That's because the frequency is equal to 1. Okay, that's my first first class. Okay, now second class, the frequency it's just 0. So in the second class, this is my this interval here represents my second class, but I mean the frequency is 0. So there's no like a box or something. There's nothing here, right? It's just 0. For the third class, the frequency is 1. So we're gonna have a box with height equal to 1. So here's again this box here. And as you can see, the height of this box, it's 1. Next class, the frequency is 6. So for this fourth class, this is my fourth class. Fourth class, the frequency is 6. So my box is gonna go up to 6, right? So here's 6, right? So I'm gonna have this parallelogram or rectangle. And the height of this rectangle is it's equal to 6 because the frequency of the fourth class is 6. Frequency of the fifth class. This interval here represents the fifth class. The frequency is 8. So I'm gonna have a rectangle with height or level equal to 8. So as you can see here, the height of this rectangle is 8. Okay. So that's for my fifth class. And then okay, and then for the last class, the frequency of the last class, it's, as you can see, the boundaries are 82.5, 90.5. So here's my sixth class, last class, and it has the same frequency as the last one, right? So the frequency, it's again 8 here. So I'm gonna have this rectangle with height equal to 8. Any question, guys? You see how it works? The rectangles. So the height of each rectangle is just given by the frequency of the class, right? Okay, I don't see any question in the chat. All right, so then here's an exercise for you guys. I think, yeah, I think we did this example on our last meeting. Yeah, so here's an exercise. And I think we didn't have time to do an exercise, so let's do one now. So exercise. So please try to draw the histogram showing the frequency of the data values, the data representing the the goals scored last season in the MLS. Eastern Conference. Okay. Remember we had 14 teams. So just to remind you the numbers. Actually, you just need the, remember for the histogram, you just need the class boundaries and the frequency. So the data values are, just to remind you the data values. So we have these data values. So we already made the frequency table, guys. So we already computed the classes boundaries and the frequency. So all you have to do is just to draw the histogram. 27, you know, we have 30, 31, 31, 34, and I think 36. Yeah, so I'm gonna give you a couple of minutes, guys, to think about this exercise. So by the way, guys, I mean, you won't have a homework this week because, you know, because we just, we're gonna just, we had just, we're gonna have just one lecture this week. But for sure, next week, I'm gonna assign a new homework, all right? So I think the next, next holiday would be the Columbus Day. So that'll be like in October. And then of course it's Thanksgiving in November. But I think that's it for the holidays. You know, so after the exercise, guys, we're gonna try to describe the shapes of histograms. And then after that, we're gonna discuss cumulative frequency. I mean, we did just a frequency and relative frequency, right? Then there's a cumulative frequency, and then we're gonna discuss the ogives. Amy, how many classes? Oh, yeah, for this, actually, this is for this exercise. Yeah, this is exactly the same example we had earlier here. Yeah, I forgot to say 4 classes. I'm sorry about that. Yeah, it's just the same example we had here. So we had like 4 classes, right? So we're gonna have the same you know, same classes boundaries, etc. Okay, so you don't have to compute again the classes boundaries and the frequency. Okay, so it's exactly the same number of classes we had in the example, the exercise we had earlier. So this is just 4 classes here, of course, just the same. 4 classes. So this is just the same same example or exercise example we had earlier. Okay. Sure. So you don't have to compute again the classes boundaries and frequency. Okay, it's I mean, we already did this, right? I can, by the way, I can just write down here again for you the classes boundaries. So just I can recall. So the classes boundaries. The frequency. So we had so for the classes, the classes boundaries, I think we had the first class was like 5.5, right? To it was 8, I think. Yeah, so 13.5. Second class was 13.5 to 21.5. Next, we had 21.5 to 29.5, and the last class was 29.5 to 37.5. The frequency, I think first class we had 2, the second class we had 4, 3 in the third class, and 5 in the last class, right? So this is just, again, it's just the same example we had earlier. So all you have to do here, guys, just draw the histogram, okay? Oops. Okay. I'm sorry about that. I'm recording, right? Oh yeah, I'm recording. Okay, perfect. Yes, just draw the histogram. Yes, yes. You know, because we don't have time to do like a new example, that would be too much for you. Yes, Amy, right? So because otherwise you're gonna need like more than 5 minutes just to, you know, to construct the frequency table. It would take a lot of time. Okay, Liana, Okay. Okay, so let's say you have 1 more minute, guys, to draw the histogram. All right, guys. Does anyone have trouble with drawing the histogram? Just you can. I mean, please let me know. I mean, in the chat, you can just write me just a private message. I mean, if you have trouble, just let me know, because otherwise, I would take more time to explain the histogram again. If you have trouble.
I'm having trouble.
You're having trouble? Okay. All right, so, okay, let's do this. So first, you need a horizontal axis, okay? Just a number line, a horizontal number line. So here, this is my horizontal axis or horizontal number line. And this horizontal number line is supposed to represent the class's boundaries, okay? So this is this line, this number line, supposed to represent the class's boundaries. Okay, so class's boundaries. Well, first, this is just a number line. So somewhere you have 0, right? This is 0 somewhere right here. And then what I'm gonna do, guys, I'm gonna just put the on this horizontal axis. I'm gonna put the values of my class's boundaries. So like first value or first class boundary is, as you can see here, it's 5.5, right? That's my first class boundary, right? So I'm gonna put 5.5 on my horizontal axis. So somewhere, well, of course, 5.5, it's larger than 0. So I'm gonna put 5.5, let's say somewhere here, okay? Then what's the next class boundary? Well, it's 13.5, right? That's the next value or boundary value. So that's 13.5. So I'm gonna put 13.5. So this is my next boundary value, right? What's the next one? Well, next class, of course, is the lower boundary It's just, again, it's 13.5, but I already put the 13.5 on my horizontal axis, right? So what will be the next value then, or boundary value then? It's the 21.5. Okay. So 21.5, let's put 21.5 on my number line. So here's my 21.5. Okay. Now the next value. Well, here 21.5. I already put 21.5 on my horizontal axis. So next value would be 29.5. Okay, so here's my 29.5. Right. Next 29.5 already done. So then that would be the next value will be 37.5. So here's 37.5. Okay. Any questions so far? Nope. Okay. Perfect. Okay. So now I need a vertical axis. Okay, and this vertical axis is gonna pass through the 0. So here's my 0. Right. So I'm gonna have like a vertical line passing through 0. Okay. And this vertical line, the values of this vertical line are supposed to represent the frequency. So this is my frequency. Of course, this is 0. Okay. Now, what are the values of the frequency here? Well, our first value, it's 2, right? And then we have 4, we have 3, and 5, okay? So we need like 2, 3, 4, and 5, right? So you start from 0. After 0, you have 1, then 2, 3, 4, and then 5, right? That's all we need here, because the largest frequency, it's 5. So I'm gonna just stop at 5 here. Okay, so you see, guys, why I stopped at 5? Because 5 is like the largest frequency. So that's all I need here. Okay, because that's the largest frequency. So you stop at 5. All right, now, what's my first the boundaries of my first class? Well, first class, the boundaries are, let me use a different color. So the boundaries are, So the boundaries are 5.5 and 13.5, right? This is the boundaries of my first class, 5.5, 13.5. So you see here the interval, this interval here between 5.5 and 13.5. So that interval is supposed to represent my first class. So this is like my first class. Okay. Please let me know. You can stop me any time if you have any question. Okay. Now, what's the frequency of the first class? The frequency, it's 2, right? So I'm gonna draw like a rectangle, and the height of the rectangle would be 2, because the frequency of the first class is 2, right? So I'm gonna draw like a rectangle right here, and the height of this rectangle, as you see, it's 2. Okay, so this rectangle represents the frequency of my first class. Okay, and again, the height, it's 2 because the frequency of the first class is 2. Does this make sense to everyone? Please let me know. I mean, I'm here just to answer your questions, guys. Don't be shy. Okay. All right, that's good. So now for the next class, I'm gonna use a different color. Let's use the blue for the next class. So next class, the boundaries are 13.5 and 21.5, right? This is supposed to be my 13.5 to 21.5. So this interval, this blue interval, right? This blue interval or blue segment, it's between 13.5 and 21.5. So that's supposed to represent my second class, right? Because my boundaries of my second class are exactly the 13.5 to 21.5, right? Now, what's the height of the rectangle in my second class? Well, the frequency is 4, right? So I'm gonna draw like a rectangle, and the height of this rectangle would be 4 because the frequency of my second class is 4. Okay. Next class, third class, it's the boundaries are, so here's my third class. The boundaries are 21.5. So here's 21.5 and 29.5. So the interval, this interval, you see this interval between 21.5 and 29.5, that's supposed to represent my third class. And what's the frequency? It's 3. So I have to draw a rectangle with height equal to 3. So you see here, this is supposed to be like 3. So the height of this green rectangle, the height would be 3. Okay, you see that the height is 3 because, I mean, if you take this like horizontal line, starting from 3, so that would be that would represent the height of my third rectangle. Now, last class is the boundaries are right here, 29.5 and 37.5. So here's 29.5. This is 37.5. So this interval between these two numbers represent my fourth class. Okay. Now, what's the height or what's the frequency? The frequency is 5. So I'm going to go with a rectangle with height equal to 5 right here. And as you can see, the height of this rectangle, it's 5 because the frequency is equal to 5. All right. Any question, guys? Well, I hope this makes sense, all right? Okay.
What is the fourth class?
The fourth class, where's the fourth class? Yeah, so the fourth class is, you see, these are the boundaries of the fourth class, right? The 29.5. So this is the 29.5 and 37.5. So here's the 37.5. So you see this red interval here? That would represent my fourth class. Okay, you see the red segment between 29.5 and 37? Well, I guess no. So yeah, this red segment here, I mean, right here, this is supposed to represent my fourth class. Now I have this rectangle, and the height of this rectangle is 5, as I said, because the frequency of the fourth class is 5. Okay, we only have 4 classes, of course. That's why I got 4 rectangles. All right. Well, I hope this answers your question. All right, guys. So then, so we know how to draw histograms. So next, what we're gonna do, we're gonna try to describe the shape, the shapes of the histograms, and try to get some information from the histogram. So there are different terms used to describe shapes of histograms. So next, so histograms, shapes. Okay, so the terms used to describe the shapes of histograms are, I'm going to try to give you examples, of course. So terms used to describe shapes of histograms. So first, histograms. Okay, so first term, it's actually called number one. It's called the skewed left or right. Skewed left or right. So what does it mean, skewed left or right? It means that one end, so one end has more or less higher frequency classes. Okay, example. Well, let's check, for example, the observed car speeds. So I remember we have this example. Where is it? The histogram right here. Okay, so we got this. We got this histogram, which actually shows the frequency, of the observed car speeds, right? And you can see here in this histogram, on the right side. So the right side, let me just. So as you can see here on the right side, the two classes on the right side, they have like the highest frequency, right? Like this one here, it's 8. This one it's 8, right? So this is an example of a skewed right histogram. So this is skewed right histogram. Okay, because one end, which is the right end here, one end has like the higher frequency classes, right? So this the example. So the idea here, well, before the example, so the idea is to have something which looks like before the example. So the shape would be something like. So the shape is like, so something like, you have something like, and then on this right end here, okay, or it could be the left side. So you can have like, so on the left side you have the classes with the highest frequencies. Okay, so this one would be skewed right, and this one would be skewed left. Okay, so again, the idea is that one end has higher frequency classes. Okay, higher frequency classes, it means that the frequency is of these classes, as you can see, for example, here, the classes on the left side, or these classes here on the right side, they have the highest frequencies, right? So here is the highest frequencies. So that's what I mean by skewed left or right, okay? Any question, guys? So you see the shapes of the example. An example would be exactly this, the observed car speeds. So in this, you see here in this example of the speeds of the cars on the highway, You see on the right side, so the two classes on the right side, they have the highest frequencies, okay? So that's why it's a skewed right histogram, okay? Make sense? Now, next shape. So number 2, or next shape, it's called mound shaped symmetrical. So, which means that the histogram is actually symmetric above the center. Okay, so the histogram is symmetric above the center. So the center of the histogram would be like a mirror for the graph. So something like, so the idea is to have the, so the shape would be like, the shape is like, so it will be something like, let's say, so here in the middle, we have this thing here. Okay. So as you can see, guys, so the middle here, the center of the histogram, this is what I mean by the center of the histogram. So right here, this is what I mean by the center. I mean the middle of the histogram, the center of the histogram. So yeah, so your histogram is going to be symmetric above this center, which means that this is like a, as you can see, it's like a sort of a mirror, right? Okay, because as you can see, like this class here, or this frequency, it's almost is equal to this one here. You know, this frequency here would be the same as this one here. This one would be the same as this one, etc. Right? So it's just symmetric above the center. So the center will be like a mirror for this the shape, right? Okay, makes sense. All right, and then, so this is kind of different, of course, from the skewed left or right. Skewed left or right, so like you have one end which has the higher frequency classes, right? So it's not symmetrical, because if it was symmetrical, then you'd have the higher frequency classes in the left and in the right. Okay. Next shape is the it's called the uniform or regular shape. So number 3. This is regular or uniform. Regular or uniform means that most of the classes, they have the same frequency. Okay, most of the classes have the same frequency. Okay. So for example, I mean, the idea would be the following. So the shape would be like, the shape is like, so all the classes, or most of the classes, that have the same, just yeah, they have equal frequency. So you're gonna have something like, which looks like something like this here. Okay. So as you can see, guys, here, I mean, most of the classes, they have just more or less the same frequency. Okay. So classes, they have more or less the same frequency. Same frequency. Okay. The last shape, so that's for regular uniform. Most classes have the same frequency. For the last shape, it's called the bimodal distribution. So in the bimodal distribution, bimodal in the bimodal distribution, let me start here. So here, bimodal distribution. So so here in this case, the two classes with the largest frequencies are separated by at least one class. Okay, so the two classes with largest frequencies are separated by at least one class. Okay, separated by at least one class. Okay, so the idea is the following. So the shape of this histogram is going to be like something like, so the idea is, so the shape of the histogram would be like, okay, so as you can see here, guys, so the two classes with the largest frequencies, of course, they're going to be these two classes right here, right? These two classes have the largest frequencies because, of course, they are the highest one. So this one here is same, has the largest frequency. Okay, so they are separated by actually how many classes? They are separated by 3 classes, right? So that's what I call the bimodal distribution. So the largest, these two classes with the largest frequencies. So here we have the largest frequencies. So they are separated by 3 classes. Okay. Oops. Are separated by 3 classes. Okay. So that's what I call bimodal distribution. Yeah, so we have these 4 kind of shapes, histograms. So just again, let me just remind you. First, we have this skewed left or right. Okay, so one end has a more or less higher frequencies. There's this mound shaped symmetrical, which means it's symmetric above the center. Then we have this regular or uniform. Most classes have the same, more or less same frequency. And then finally, this bimodal distribution, okay? So what I'm gonna do, guys, let's have an exercise. So in this exercise, you try to describe the shape of the histogram, okay? Try to just try to find the corresponding shape, okay? So here's an exercise. Oops, sorry about that. Exercise. So all you need to do is just describe try to describe the shape of the histogram. So what do I mean by describing the shape of the histogram? So as I said, there are like four different terms to describe the shape of histograms. So you need to specify what will be the shape of the histogram, right? So, so number one, so let's say you have the following histogram. Number one. So that'll be something like, okay, so what will be the shape of this histogram? So number one, number two, number two. Okay, number three. Okay. Okay, guys, just give you a couple of minutes to think about this exercise. Again, all you have to do is say what will be the shape of this histogram. All right. So again, guys, please don't forget your homework. It's due this Wednesday. If you submit your homework, I guess, if you submit your homework late, I won't accept it, okay, unless you have a valid reason, okay. So please try to submit your homework on time. All right. So any guess for number one? What will be the shape of the first histogram? Unitary distribution. Amy, unitary distribution. You mean like a uniform, right? Yeah. So number one, I mean, like the frequencies of the class. Yes. Oh, okay. Perfect. Then yes, you're right. So then yeah, the frequencies of the first the frequencies of the classes are more or less the same, right? They have more or less the same height. So the rectangles, they have more or less the same height. So the shape would be uniform or regular. Okay, so yes, Amy. So this is a uniform histogram. So again, because the frequencies are more or less the same. What will be number two? What will be the shape of number two? Any guess? Um, it's actually right. Right skewed. Right skewed because yes, Amy. Thank you. So it's right skewed. So because so on the right side, as you can see here, on the right side, the classes, they have the largest frequencies, right? So that's right skewed. Yes. No problem. Now, what about number three? Any guess for number three? The shape of number three?
Is it mound?
Well, mound would be like, you know, it would be like symmetrical above the center, which is, well, I won't say it's symmetrical above the center because you see like here on the right, on the left side, this class here or the frequency of this class is not really the same as this one, right? They're not exactly the same, right? So remember, mound was like symmetrical above the center, right? You see like here on the you see like here on the left side and the right side, they have exactly the same, you know, the same height. Well, here it's not, I mean, they don't really have they don't really have the same height, right? The one on the left and the one on the right, kind of different. So I wouldn't say it's mount here in this case, but I would say it's not, yeah, it's bimodal, Amy. Yeah, so it's not uniform because, I mean, they don't really have this, the classes here, they don't really have the same, more or less the same frequencies. It's not right or left skewed, right? Yeah, so here it would be, I would say, I mean, it's actually bimodal. Bimodal distribution. So in bimodal distribution, guys, so the two classes with largest frequencies. So as you can see here, these two classes here, the two green rectangles, they have the largest frequencies, and they are separated by more than one class, right? So they are separated by like three classes here. So yeah, so it will be a bimodal distribution. Okay, all right, guys. Next, yeah, next it's cumulative frequency. We didn't do the cumulative frequency, so now it's time to do the cumulative frequency. So, I mean, we did the, you know, in the frequency table, we had the column with the frequency and then relative frequency, and then there is the cumulative frequency. So let's move now to the cumulative frequency. So cumulative frequency and ogives. All right, so what's the cumulative frequency? Well, cumulative frequency is just the sum of the frequencies for a class and all classes before. So let me just write it down here. So the sum of the frequencies for a class and all classes before it. So this sum here, it's called the cumulative frequency. So that's what I call cumulative frequency. Okay, so an example. Example. Well, let me just remind you the example with the observed car, car speeds. So let me just remind you here. So the example of observed the example of observed, I think we had 24 cars. Yes, I think 24, right? Yeah, so 24 car speeds. Okay, so just remind you the frequency table. In the frequency table, we had like, so the frequency table, so just remind you the, the values of the class limits. So here we had, I think, classes boundaries. Just to remind you here. Let me just use the red. So classes boundaries. So we had I think six classes again. Just remind you the classes boundaries and the frequency. So now I'm going to add, I'm going to show you how to compute this cumulative frequency. So here I'm going to add another column with the cumulative frequency. Okay. So first, let me remind you the classes boundaries. Classes boundaries, we had first class, I think it's like 42.5 and then 50.5. 50.5 and then 58.5. And then the third class was like 58.5 again, then 66.5, 66.5, and then 74.5, 74.5, and then 82.5, etc. And this is 90.5, of course. And then the frequency we had like one, for the first class it's 1, second class was 0, 1, and then it was 6, 8, and 8. Sorry. So now I'm gonna compute the cumulative frequency, right? So what's the cumulative frequency? We said it's the sum of the frequencies for a class, and so for a class and all the classes before it. Okay, so First class, well, there is no class before the first class, right? This is just the first class. So the cumulative frequency here is gonna be just the frequency, the frequency of the first class. So the frequency here is, it's 1. Okay. Now for the second class, the cumulative frequency is equal to the frequency of the second class plus the frequency of the first class. So the frequency of the second class, I mean, it's 0, plus the frequency of the previous class, which is first class, right? Which is 1. So it's 0 plus 1. So cumulative frequency here would be 1. For the next class, so that's the frequency of the third class plus the classes, the first and the second. So the third class, the frequency of the third class is 1. The frequency of the second class is 0. And the frequency of the first class, it's 1. So that'll be 1 plus 0 plus 1. So it's equal to 2. Okay. For the class number 4 or fourth class. So the cumulative frequency is going to be the frequency of the fourth class plus the frequencies of all the classes before it, right? So it's going to be 6. And before 6, we had 1. Before 1, we had 0. And before 0, we had 1, right? So then the sum would be 8. So the cumulative frequency of the fourth class would be 8, okay? Now, what's the cumulative frequency of the fifth class? Well, it's the frequency of the class itself, which is 8, plus the frequency of the previous class, which is 6. The one before the third class, that's 1. The second class is 0, and the first class it's 1. So that will be equal to, so it's 8 plus 6, that would be 14, plus 1, 15 plus 1, that would be 16. Okay. And finally, what will be the cumulative frequency of the last class? So it's the sum of the frequency of the last class plus the frequencies of all the classes before it, right? So before the last class, we have the fifth class, which is the frequency is 8. Before that, we had 6. Before that, we had 1. Then we had 0, and then we had 1, right? So then the cumulative frequency of the last class is actually equal to 8 plus 8, 16, plus 6, 22, plus 1, plus 1, that will be 24. Okay, so it's 1, 1, 2, 8, 16, and then 24. Okay. So again, it's the sum of the frequencies for a class and all the classes before it. Okay. Well, let's do the cumulative frequency for the goals scored by the MLS teams. Okay, so here's an exercise. Okay, so please try to compute cumulative frequency of the goals. So again, this is an example we had earlier. So a goal scored by the 14 MLS teams. So just to remind you of the classes and the frequency, and all you have to do, guys, just to compute the frequency cumulative frequency. Okay, so just to remind you here, cool. So we had 4 classes. So classes boundaries. So here is the frequency, and you need to find the cumulative frequency. All right, so let's just remind you the classes boundaries of this example. So we had 4 classes. The first class was like 5.5 to 13.5. And then second class was like the boundaries was like 13.5 and 21.5, 21.5, and then 29.5, and then we had 29.5, and then 37.5. Okay, frequencies. So 2, 3, 4, and it's 2, 4, and then 3. Sorry. Frequency of the second, we said the second class, we said it's 4. Frequency of the third class is 3. Frequency of the last class is 5. Okay, so what you have to do, guys, you have to find the cumulative frequency, right? So of the first class, second class, third, and the fourth class. Okay, so I'm going to give you a couple of minutes to find the cumulative frequency. So again, this cumulative frequency, it's different from the relative frequency, right? So we have frequency, relative frequency, and then now we have this cumulative frequency. So again, just to remind you guys, we won't meet this Wednesday because there are holiday. I mean, there are holidays, I think. So there are no classes scheduled this Wednesday and Thursday. So our next meeting would be next Monday, of course, online.
I don't like online. I like in person.
Oh, well, yeah.
But it's okay. No problem.
Yeah, I mean, as I said, I mean, as I explained, weeks ago, it's not up to me, right? So
Exactly.
probably, as I said, guys, I will assign new homework number 2 next week. Okay, not this week because we won't meet on Wednesday. So that's the reason why we don't have a homework number 2 this week. So we'll have one next, a new homework next week. All right, what time? Okay, we have 4 minutes. Okay, guys. So any guess for the cumulative frequency of the first class? So for the first, let me just erase this here. All right. Just use the green, I guess. Okay, so what will be the cumulative frequency of the first class? Any guess? So, okay, so the cumulative frequency of the first class is just going to be the same as the frequency. Okay, it's always the same as the frequency. For the first class, it's always the same, okay? So here we have 2, so then cumulative frequency is 2, right? So like here in this example, frequency of the first class is 1, so cumulative frequency it's also 1 because there are no classes before the first class, right? There are no classes before the first class. The first class is the first one, right? Now, what will be the cumulative frequency of the second class? Any guess? 6, Amy, thank you. Yes, absolutely. It's gonna be 6 because that's equal to the frequency of the second class. So the frequency of the second class is 4, right? Because we have 4 here. And plus the frequency of the class before. So which is the first class. And the first class, the frequency of the first class is 2. So that's why we have 4 plus 2. And so the answer would be 6. Okay. So before 4, we had 2, right? So that's why we have 4 plus 2. Now, what will be the frequency of the, yeah, Shakwana, very good, that's 6. What will be the frequency of the third, cumulative frequency of the third? Thank you, Amy. Absolutely, Alicia. Yes, very good, guys. So that'll be 9 because, so frequency of the third class is 3 plus the frequencies of the classes before the third class. So the frequency of the second class, which is 4, plus the frequency of the first class, which is 2. So that will be, as you said, guys, exactly 9. And finally, well,
And
the
that's what
14. Yes, Alicia, very good. It's 14 because that's the frequency of the fourth class plus the frequencies of the classes before it. So plus the frequency of the third class plus the frequency of the second class. Sorry, that would be 4 here. So frequency of the second class, that's 4, plus the frequency of the first class, which is 2. So there'll be 8 plus 4, that's 12 plus 2, that's 14. So the answer is 14. So that's the cumulative frequency. Okay. Any question, guys, about this exercise? Okay, so that's,
yeah, the numbers.
I don't really hear you well. You had the question about the 6?
Yeah, I am confused.
Yeah, well, okay, this cumulative frequency, all you have to do is to take the sum of the frequency of the class plus the frequencies of the classes before it. Okay, so for example, well, for the first class, so it's going to be equal to 2 because there are no classes before the first class. So we only have 2 here. Okay, that's so for the first class, it's always the same number. The cumulative frequency is the same as the frequency. For the second class, so for the second class, it's going to be equal to the frequency of the second class. So that's 4, right? So this is 4, sorry. So it's 4 plus the frequencies of the classes before the second class. So before the second class, what do we have? Just the first class, right? And what's the frequency of the first class? First class, the frequency of the first class is 2. So there'll be 4 plus 2. Okay, so that's why I got 6. Does the 6 make sense? Let me see. Okay, and okay, sorry, last minute, in this last minute, let me just explain. So for the third class, let me just erase this thing here. I'm gonna explain it again. So for the third class, it's the frequency of the, come on. So the frequency of the third class is 3, right? Because we have 3 here, and then plus the frequencies of the classes before. So before that, we have 4, and before 4, we had 2, so it's plus 2. Okay, that's why we got 9. And finally, for the last class, the frequency of the last class is 5, plus the frequencies of the classes before it. So it's plus the 3, plus the 4, and plus the 2. Okay, so then the sum will be 14. All right, guys. Anyway, I have to stop here. I guess we're gonna continue with this cumulative frequency because we're gonna use it for the ogives. So we're gonna discuss, I guess, again this cumulative frequency next time. Thank you everyone. Thank you for listening, and I will see you next Monday. Take care, everyone. All right. See you next time.
Bye.
Goodbye. Good night.
Good night. Good night.
Good night. Bye.
Bye. I'm gonna stop.